Hello friends and welcome to YouTube channel Freedom Tech, and in this session what we are going to learn. In this session we are going to install YOLOv8 and YOLOv8, also YOLOv8 segmentation on latest Raspberry OS Bullseye 64-bit version. So before we move to our practical, friends, if you learn something from our videos, please consider to subscribe our channel. Okay friends, thank you so much. And let's get started. So friends, as I mentioned, in this session we are going to install YOLOv8, YOLOv8, YOLOv8 segmentation on Raspberry OS Bullseye 64-bit version. Okay, we are going to solve the error and then we are going to run our code. And I have here USB camera which I have connect with the Raspberry Pi 4. So we are going to detect object live with the help of YOLOv8, YOLOv8 segmentation and YOLOv8 on our Raspberry OS Bullseye 64-bit version. So for that, first just open Thony Python IDE, go to the menu, programming and Thony, just click on and it will open Thony Python IDE like this way. Okay, so this is what our Thony Python IDE, simple. So now you need to go here, tools, manage packages. It will open this kind of window, manage packages, and first we need to install the latest OpenCV version on our Bullseye. So OpenCV-Python, okay, OpenCV-Python, click on search on PyPy, and the first package, as you can see, OpenCV-Python, just click on it, and this is the latest version 4.7.0.72, which I have already installed. You need to simply click on install button and it will automatically install latest OpenCV version on our Bullseye 64-bit version. So I have already installed OpenCV. So let me show you. If I go here inside the shell and if we import CV2, so as you can see we have successfully import CV2. So let's just check the version, cv2.version, like this way. If I hit enter, so as you can see this is our version, which is 4.7.0, the latest version on fresh install Raspberry OS Bullseye. This is completely new Raspberry OS Bullseye, fresh installation, simple. So we have done with CV2. So now we need Ultralytics. So when you install the Ultralytics, of course it will install Torque, which basically need for YOLOv8. So you need to simply install Ultralytics. Same thing, go to the tools, manage packages, and here of course we are going to search for Ultralytics. Okay, Ultralytics, click on search on PyPy, it will search for Ultralytics. YOLOv8 first package, just select it, and as you can see I have already installed Ultralytics, that's why it say uninstall. So you need to simply click on install button and it will install Ultralytics on our Bullseye 64-bit version. That's it, we have done with package installation. Now friends, we successfully import CV2, there is no error. Okay, so now if we want to use YOLOv8, so we need Torque. So simply if I import Torque, hit enter, as you can see process enter with exit code -4, or we can say -4. So this is the error for importing Torque on Bullseye. Okay, now let's just call our Ultralytics for YOLOv8. We call import Torque, there is error. Okay, no problem, but let's just call Ultralytics for YOLOv8. So let's just say from Ultralytics, from Ultralytics we are going to import YOLO. This is how we call our module for YOLOv8. From Ultralytics import YOLO. If I hit enter, and as you can see for YOLOv8 we have two error. This one is the first error, as you can see URL lib3, and this one is the same error which we have for importing Torque, the process ended with exit code -4. So this is the error which we face for latest Raspberry OS Bullseye for installing the YOLOv8, also the YOLOv8. So how to solve this error? This error is basically for Torque version. We need Torque version 1.8.0. Okay, so when we install the Ultralytics, it will automatic install the torque version 2.0 something. Okay, so let's just search. So go to the tools, manage packages. So because we install Ultralytics, so Ultralytics automatic install the torque version, because the torque is basically the dependency for Ultralytics. So we need to simply search for torque, which already installed. Okay, so torque is here, and as you can see, as I mentioned, torque install 2.0.0. so this is the latest version of torque. But for running without error Ultralytics, also the torque, we need torque version 1.8.0. so we need to remove this first torque version. So simply just click on uninstall, and it will uninstall torque 2.0.0 version on our Raspberry OS Bullseye. Okay, there is no need to uninstall Ultralytics package. We only want to uninstall the one package, which is torque. So we have done. Okay, now what we want to do? For perfect version, I have create a repository. I will mention the link. You need to simply copy and paste the link inside the browser. In that link, we have YOLOv8 script, Python script, then YOLOv5 Python script, then we have YOLOv8 segmentation script. Also we have install.sh bash script, which basically fix all the error for YOLOv8 and YOLOv5. Simple. So you need to simply copy and paste the link inside the browser, then go to the code, click on download zip, and it will download zip format repository, which we have downloaded. As you can see, just click on here, show in folder, then this is what our repository in zip format inside our /home/pi downloads folder. So let me just minimize the browser. So first we are going to extract our repository. So right click, click on extract here, and it will extract our repository. So this is what our repository is. Just click on it. So as I mentioned, first we want to install the dependencies. So of course we need to run our bash script. So let's just open our terminal. Open the terminal. I hope you all see clear. This is what our terminal. So we need to go inside downloads folder, because our repository inside the downloads. CD space D capital downloads, just press the tab button, it will auto complete our folder, which is downloads. If I run ls command, as you can see, this is what our folder. Simply run the cd with the folder name, which is YOLOv8 and YOLOv8 rpi4 main. So now we are inside our folder. So if I run ls command, and here it is, as you can see, this is what our bash script. So we need to give the full permission for bash script. So simply we are going to run the command sudo chmod 775 space our script name, which is install.sh. If I run ls command, as you can see, now it's green, means we have successfully given the full permission. Now we are ready. We need to simply run our install.sh. So run the command like this way, bash and install.sh, and just hit enter. Now it will install all the required packages for YOLOv8 and YOLOv5. Okay, so it will take some time. Meanwhile, I will pause video. So friends, the installation is still ongoing, but meanwhile installation, you will see this kind of warning message. Just ignore it. This is not error, just ignore. Okay, so friends, we have successfully completed our bash script. So we have now perfect version for running on YOLOv8 and YOLOv5 on our Bullseye. So we have done. Now if I open Tony Python IDE again, and let's just clear first our shell, clear shell, and let's just try to call our model again. So import torque, and boom, there is no error. So let's just call our YOLOv8 from Ultralytics. From Ultralytics, we are going to import our YOLO. And boom, means we solve the error. We successfully now call our import torque for YOLOv8 and from ultralytics import YOLO for YOLOv8. It means now we can use YOLOv8, YOLOv8, object detection, also YOLOv8 segmentation on our Raspberry OS Bullseye 64-bit version. That's it. Now simply we are going to test our models with the help of our Python code. So we have our code ready. So let me just call our files. So click on open and it will open our folder, and we have our repository inside downloads folder, YOLOv8 and YOLOv8 main repository. So let's just first start with normal object detection. So we are going to first use YOLOv8 main.py is basically object detection with the help of USB camera. Okay, so main.py, and as you can see we have here our main.py, which is basically for YOLOv8, simple YOLOv8. So this is the basic code which I have already explained in previous videos, same code which we use on our Windows machine, same code. Okay, so here of course I am in front of the camera, so condition is what we are going to only detect the person. So simply I have created here if person in our coco.txt. So I have mentioned here coco.txt inside our repository. So we have our class file name, of course, and we are going to use here YOLOv8 and.pt model because we are working on our Raspberry Pi 4 machine. So I have mentioned here just a minute. As you can see, I have mentioned YOLOv8 and.pt model. Simple. So this is the basic code. So if I run the code, of course I have connect the USB camera, and here I have called the USB camera. Just a minute. If I scroll down, here it is. As you can see, cap is equal to cv2.video capture 0. 0 is basically the index number of my USB web camera because I have here only one camera. So of course 0 is the index number. If you want to run any MP4 file, video file, simply remove the 0 and mention the video file link, video.mp4. Then it will of course detect the object from video file. So now we are going to detect the object live with the help of our USB camera. Simple. So if I run the code, of course it will first download YOLOv8 and.pt model, and then we have the frame and we have the detection with the help of YOLOv8. So let's just first download the model. Oh, there is error, but this is not an error basically because I have mentioned here a CV zone model. So I forget to install CV zone. So let's just install CV zone, because we are going to use here CV zone for put text method from CV zone. So let's just install CV zone, click on search on PyPy. We have CV zone here and click on install. It will install CV zone on our Bullseye 64-bit version. I have done. Now simply we are going to run our code, and as you can see friends, it's now downloading YOLOv8 and.pt model for object detection. And remember one thing friends, right now I am recording, also we are going to detect the object, so it will take some time. Okay, it will take some time because I am same time recording, and as you can see it's detecting me as a person. Here it is, as you can see, the person, a text, and there is a rectangle. So rectangle, let me increase the rectangle thickness. Okay, so here I have mentioned 1 is the thickness, so let's just mention 2, and if I save the code, if I run the code, and as you can see it's detecting me as a person. There is a rectangle and there is a text which is the person. It means we have successfully run our YOLOv8 object detection on our Raspberry OS Bullseye 64-bit version. That's it. Now we are going to simply cross check with YOLOv8. So file open, and for YOLOv8 I have created the YOLOv8.py if there is any error. So this is what our YOLOv8. We are going to use YOLOv8 as pre-trained model, and same code. Okay, same code. As you can see here, we have a bounding box. Then if the person in D means if the person in file, the coco.txt file, of course we are going to detect the object, because I have here only one class, because I am in front of the USB camera, so we need only one class. There is no need to detect another classes. So simply if I run the code, it will download the model, the basic pre-trained model, and then of course we have detection. So as you can see, now it's downloading the pre-trained model. And friends, we have done, there is a detection as you can see. So but what we are going to do here, I have mentioned cv2 put text method. Okay, so what we are going to do, we are going to simply copy paste cvzone method. Okay, so we have our main.py, and we have inside main.py we have our cvzone method, because it's look really good. So just copy it, the method, you open YOLOv8 our code, and here we are going to paste our cvzone method. Okay, and then what we are going to do, there is no need to cv2 put text method, so we are going to simply remove this line. Okay, remove it. If you want to go with cv2.put text method, you can simply go with cv2.put text method. Okay, there is no problem. And here I am going to increase the there is no need to increase text size basically. And let me see if I have called the cvzone over here. So there is no cvzone, so import cvzone. I hope now it's really good. And here I need to mention the variable. So variable is basically d. So let's just say I need to mention d here. Okay, d, because d is basically our names. So if I save the code, if I run the code, and as you can see friends, we have object detection with YOLOv8. There is a rectangle and there is a class name which is the person. Okay, so we successfully detect the object with the help of YOLOv8 and YOLOv8 on our Raspberry OS Bullseye. Of course, it is really slow because friends, I am same time recording on a Raspberry Pi 4 Raspberry OS Bullseye, so that's why it's really slow. Okay, in your case, it will not that much slow. Okay, simple detection. Now simply we are going to open our segmentation code. So go to the file and open the segmentation code. So we have main1.py. This is basically our segmentation code, and we are going to use here this file YOLOv8 segmentation.py. So inside YOLO segmentation.py, I have created the code, I have created the class. This class is basically help us to give B boxes, class IDs, segmentation contours, and scores. So as you can see, I have mentioned return B boxes, class IDs, segmentation contours, IDX, and scores. Okay, so we need to call our class. We need to call our YOLOseg class inside our main1.py. So here it is. As you can see, from YOLO segmentation, this is what our file name, YOLO segmentation. We are going to call YOLOseg. Okay, this one, YOLOseg. We are going to call YOLOseg our class. Okay, and then ys is just a variable. Ys is equal to our model, which is YOLOseg. As you can see, YOLOseg. And then of course we are going to again use YOLOv8 and -seg.pt, which is pre-trained model for object detection. Of course, now the same code we are, as I mentioned, we are going to use here our class YOLO segmentation. So we are going to use, from this code we are going to use a detect function. Okay, so here it is. As you can see, this is how we read our frame, and then as we return here, B boxes, class IDs, segmentation contours, IDX, and scores. So simply we need to call all these things over here. B boxes, classes, segmentation, scores is equal to our ys, which is our model, ys.detect. What is detect? Detect is basically our function. detect is our function, so we need to call that function over here with our variable ys. This one is ys here, and detect is our function. Simple. And of course we need to pass our frame. Then we will get the b boxes, because we return here, we return what we return, b boxes, class id, segmentation contours and scores. So we will return b boxes, classes, segmentation and scores. Is basically for loop b box, class id, seg and score. So of course now we have b box, so it means we have 4 coordinates for drawing the rectangle. This is the basic code for drawing the rectangle. So of course x, y, x2, y2 is equal to our b box. Simple. Now here we are going to use basically our coco.txt file, and we are going to read the classes from that file. So c is equal to classes list is and class id, which we mention here, class id. So it will take the class id and it will basically read the file with the help of class id, our coco.txt file with the help of our class id. And of course I have here only one class, so I have mentioned if person in C. You can mention any object as per your requirement, or you can simply remove the if condition and you can detect any object which we have by default. Simple. Okay, so this is how we will get the rectangle. Then of course we have here a segmentation, so we can simply draw the polylines for each object. Okay, so what we are going to do, first only draw the rectangle. Okay, so let me comment all other things. Okay, so now we are going to only draw the rectangle on the object with the help of our segmentation, YOLOv8. Okay, so if I run the code, again we have here our USB camera. Of course you can use a Raspberry Pi camera also. You need to simply connect the Raspberry camera with the Raspberry Pi 4. If you don't know how to connect the camera, I have already created the video, watch video, then you will get the idea. Then same thing, you need to simply mention the index number. 0 is the index number for Raspberry Pi camera also. If you have more than one camera, so just mention a particular index number. Okay, 1, 2, 3. Okay, so we are ready. We have downloaded our model, and our frame is also ready. And as you can see friends, we are detecting the object, means I have here there is a person and we have a rectangle, and the person is basically the class. As I mentioned, it's really slow because same time I am recording, and of course we are working on our Raspberry Pi 4 friends. Okay, so simple. So we have done with rectangle. Now because we use the segmentations method, so we can simply draw the mask. We can simply draw the mask on the object. Okay, but first we can draw here polylines also. So let's just uncomment cv2.polylines method, and I am going to simply save the code. I have comment the cv2.rectangle method. I have uncomment the cv2.polylines method. Now we can see the polyline on the object. Okay, there is a polyline on the object. So friends, as you can see, there is a polyline. Here it is. As you can see, this is the polyline for object. We have person, so there is a polyline. Here it is. As you can see, the red color polyline on the object. So we successfully draw the polylines because we have segmentation, so we can simply draw the polyline on each object. Okay, so now we have done with polylines. So we need to simply mention the mask on the object. For that we have here cv2.fillPoly method. Okay, and overlay is basically our frame.copy. Here it is. As you can see, overlay is equal to frame.copy, and this is the method. Alpha is basically the channel 0.7, and then we have of course the mask on object. Okay, so if I save the code, if I run the code, and friends, as you can see, we have red color mask on object because we mentioned here a red color 00255. So there is a red color mask on frame. So you can simply change the mask transparency with the help of this alpha. Okay, now I have mentioned 0.7. so if you want to change the transparency of the mask, you need to simply change this coordinate. So let's just say if I want to mention 0.3. okay, so I have mentioned 0.3. if I run the code, now my friends, as you can see, the transparency is changed. Okay, you can see the mask, the red color mask, the transparency is changed. Now again I am going to mention, let's say 0.8, and if I save the code, if I run the code, and friends, again you can see the transparency of our mask is changed. So friends, this is how you can simply change the transparency of the mask. Okay, so I hope you all clear. I have shared full code for YOLOv8, YOLOv8 object detection, also YOLOv8 segmentation. So you can simply use this code for your project. So we solved the error also. So I hope you learned something from this video. We'll meet our next video. Till then, thank you, take care, and bye bye.